In oceanography, the first and foremost chapter is to study ocean bottom relief, its characteristics. Regarding the origin of ocean bottom and continents, we have studied a number of theories propounded by geomorphologists and geologists. But today we have to study the topography or the ocean bottom relief which is below sea level. What is sea level? Why sea level is taken as criteria to compute or to measure the height above and depth below? Why not ocean level? So it is very simple to understand that oceans are the vast water bodies and they have ellipsoid or spherical shape, curvature, because the water body lies on the earth. Earth itself is of geoid shape and has curvature, hence the water surface also has curved surface. And if from the middle of an ocean you take criteria to measure the height of a mountain on a continent, so it will be difficult and erroneous. That's why the sea level is taken into consideration, not ocean level. What is sea? Sea is a small part of water body which is adjacent to continent or land. For example, Sea of Japan, Arabian Sea, South China Sea, Caribbean Sea. A number of seas are there which are near to the continents. That's why sea level is taken criteria, not ocean level. So take example, suppose this is the sea level and above sea level this is continent and on that this is mountain peak. Below sea level this is ocean and the deepest point is this. As we have studied in geomorphology that above the sea level first it is plain, then plateau, then mountains, and there are also a number of micro landforms on plain, plateau, mountains developed by exogenic, fluvial, glacial and other processes. In the same way, below sea level there is mountain, plateau, plain, or say deep sea plain. So depth of water body or ocean is shown with this triangle while height with this triangle. And as we get slope while climbing up the mountain top, in the same way we get slope while reaching the deepest point. One noteworthy thing is that the highest point of our planet, the Earth, means Everest, is 8,850 meters from sea level, while the deepest point, Challenger Deep in Mariana Trench, is 11,034 meters from sea level, and this sea level is supposed to measure, is taken as criteria to measure the height from sea level and depth. Although sea level varies from time to time, means temporally, but sea level varies also spatially. If you see on the globe today, there is sea level variation. For example, if you compare the sea level of Bay of Bengal and Arabian Sea, there is 30 centimeter difference between the two. It means the Bay of Bengal sea level 30 centimeter higher than that of Arabian Sea. Likewise, if you study the sea level around United Kingdom, there is about 80 centimeter variation in the sea surrounding United Kingdom. That's why United Kingdom has taken the sea level near Newlyn, Cornwall as standard to measure the height of land and the depth of ocean. Likewise, in India, before independence, sea level at Karachi was considered as base. After independence, Chennai sea level was taken to measure height and depth. But today, the Survey of India has decided to consider the sea level at Bombay High to measure height and depth of the places. Thus, sea level of all the countries is because of difference in salinity, temperature, and that's why currents, tides, waves move in the sea level. One very important point that sea level undergoes change due to glaciation and global warming. Today, sea level at global level is rising, but in Carboniferous and Pleistocene periods, the sea level experienced negative change. This is the concept of sea level and criteria of taking sea level to compute height and depth. Contrary to it, on Moon there is no water body. That's why the highest peaks height is measured from the deepest point. But here it is the water body, ocean, which covers about 71% area of the earth. Now let us start a journey to study the ocean bottom relief. This is a simple and generalized model to have concept of ocean bottom relief. But we will study these landforms independently of Pacific Ocean, Indian Ocean, and Atlantic Ocean. You are standing here, suppose it is east coast of North America, and you have to reach here, suppose it is West European coast, and your means Americans' ancestors are waiting here for their arrival. You have two ways to travel. One, if you are blessed with moving on water with naked foot and you will not drown, you can travel at this sea level, but you may experience the water topography there. In water also there are relief features which are of water. For example, wave, tide, current, tsunami, etc. So this is one journey that we will travel later on while studying current, tide, tsunami. But today the reference is that you have to climb down here and make a journey through this. If you have problem to move in water, you can call Agast Muni and he will drink entire water of oceans and it will get dry. Then you can travel it on naked foot very smoothly. But it is not practical today to call Agast Rishi. Rather, in the name of Agast Rishi, technology is there as sonar. Especially sonar waves are released from the ships, and on the basis of echo and speed of echo, time taken, the depth of all the relief features is computed, and on the basis of and nearly the depth of all the features of all oceans have been computed. According to that, a conclusion has been arrived, and this very simple model has been formulated. If you start from here, so your journey is on the ocean bottom, and there is relief like on land, plateau, on land, plain, plateau, mountain. So your first topography is continental shelf. Continental word contains continental, you will remember. Then continental slope, again continental. Here continental rise, continental. It means these may be part of continental crust are associated with that. But oceanic deep, oceanic ridges, oceanic trenches, these differ. It means those belong to oceanic crust. This will be discussed later on. But before that, let us study that continental shelf is in the vicinity of continent and its depth is on an average 100 fathom. 1 fathom is about 6 feet. 100 fathom means 600 feet. And its slope is very gentle, 1 degree to 3 degree. And its width is 48 kilometer. 48 kilometer means from here, from the mean sea level, if you measure with the help of a tape, about 40 kilometer width it has, and their depth is 100 fathom, and its area is about 8% of world ocean area. And this is very important thing to keep in mind, that the average width of continental shelf, which has enormous marine resources, is 48 kilometer, and in this belt mine has maximum interference in water body. But this width varies because along the coast of most of the continent this width is applicable, but where there is trench adjacent to the continent, it is shorter than the 48 kilometer. For example, if you take circum-Pacific belt, which has a number of trenches, and if you move from continent, there is a sudden depth due to presence of trench. There, this width will decrease. Now, second is continental slope. So, below this continental shelf, it is continental slope. The depth of continental slope varies from 200 meter to 2000 meter. Here it is 200 meter, then here it is 2000 meter. And its slope is more because its name is continental slope. Its slope is more than 5 degree and its area is 8.5% of the ocean or water body. One important thing is that between the continental shelf and continental slope, there is a transition zone which is called turbidity flow or turbidity current. Why? Because up to this slope is gentle, but here slope has abrupt change, and with the result the terrigenous material brought down with undertow or subsurface current is carried up to this point, and it, due to steep slope or break in slope, suddenly falls, forming a turbidity in water, and it is called turbidity flow and turbidity current. One question arises, why the movement of this terrigenous material or beach material along the bottom? It is so because here waves are rising and they are eroding from the land, material brought down by them. Secondly, tides occur, tsunami occur. That's why in sea surface there is disturbance, the impact of which is experienced on the coastal land, and the material eroded is carried along the bottom and it falls here suddenly, which is called turbidity flow. Here water is very much muddy, then water will become fresh. Next point is here marginal plateau. The depth of marginal plateau is 2000 meter to 2004 meter, As we have studied plateau on continents, these are of flat-topped, made up of hard rocks. So, in the ocean bottom, there is a marginal plateau. Why marginal? Because it is located at the margin of the continental slope or margin between the ocean deep and the continental crust. And the best example of this marginal plateau is Bromley Plateau. If you see the South Atlantic Ocean map to the east of Argentina and Brazil, there is a Bromley Plateau in South Atlantic Ocean, which is example of marginal sea. Next comes continental rise. Continental rise is also part of continental crust, depth of which is 2,800 fathoms and its slope is gentle. Continental rise is characterized with the deposit of fines. As alluvial fines and cones are found at the foothill of mountain, for example Himalayan mountain, on land, in the same way here fine deposits are found which are the product of continental crust or the continental shelf slope and plateau. Thus this is continental rise and its depth and slope you have studied. Then if we go in deeper, it is called oceanic deep, and here this is oceanic deep or deep sea canyon or trench. From here to here, this is oceanic deep, deep sea canyon or trench, and its depth is above 6,000 meters from sea level, and its area is about 7% of oceans. And in this trench, the deepest point is called oceanic deep. The best example of it is Mariana Trench to the east of Philippines. And in Mariana Trench, there is the deepest point which is called Challenger Deep, the depth of which is 11,034 meters. Thus, these are the deeps and trenches. One very important information that circum-Pacific belt has a number of trenches and deeps, and deepest points in ocean are found there. Next, if we rise up and above this, it is deep sea plain, or it is also called abyssal plain because of their deep nature from sea level. Their depth varies from 3,000 to 6,000 meters, means from 3,000 start, but up to 6,000 they are deep, and the area they cover is 75.9% of the world ocean. Slope is very gentle, and this covers the largest area of ocean body. And one thing that this is made up of basaltic deposition because this is the result of seafloor spreading and basalt deposition. And if you go up here, you can see this feature. This feature is mid-oceanic ridge. According to plate tectonic, here there is a fissure or rift, out of which magma from a asthenosphere comes, and it is deposited both the sides. Both the sides are higher, while middle is lower. This middle is called median valley, and both the adjacent higher are called mid-oceanic ridge. And you might have studied in plate tectonic that there is mid-oceanic ridge in all the large oceans. For example, mid-Atlantic ridge, mid-Indian ridge, mid-Pacific ridge. And warm or hot magma comes continuously of this, and here there is a seafloor spreading when this hot magma is deposited, it cools down in contact with water. But if some marine phantom is living here, then if some marine devil is living here, then that devil has to live in low temperature. There is -2 to -4 degrees Celsius temperature. Fed up of cold water, that phantom will try to enjoy warm water and take rest. Here, some basalt is deposited in the form of pillow. That's why it is called lava pillow, and maybe that this ghost might be enjoying, this phantom might be enjoying here the lava pillow. Now, after this mid-oceanic ridge, you move here. This is a low-lying area. Again, the sea is deeper. It is called ocean bottom. We are traveling on a ocean bottom. Here, some land which is raised above the sea level is called island. And island are the small areas which are above sea level and in the vicinity and located in the vicinity of main continent. Now from this island you have to reach your target, means it is suppose West Europe, and here is very small sea that is called marginal sea because it is located on the margin of main continent. It is also called Epieric Sea and it is also called epicontinental sea. Why? Because it is near the main continent. One homework for you is that you make a list of epicontinental or marginal seas, for which you will have to watch your atlas and find the main continent and the island or island arc near the main continent. For example, Japan is island group. Between Eurasia continent and Japan, there is Japan Sea. Likewise, China Sea is also its example, Caribbean Sea. This way, a number of marginal or epicontinental seas are found. They are of paramount significance because the mainland and the island both are related with it, and there is rich biosphere and other marine resources for which dispute is being created there, and the law of ocean has been formulated by UNA. So your first effort should be to identify, locate these on the map. This is all about the ocean bottom relief. Here you have to learn these points with increasing depth. For example, first the shallowest one will be continental shelf, then deeper than that will be continental slope, in between turbidity flow, then again marginal plateau, then again continental rise, then again this deep sea plain, then again this trench, and this will be deepest. Because you may be expected to arrange these with increasing depth. One other aspect to study is that here it is continental. Above it, these are continental, and below it, these are oceanic. It means we have to turn the pages of geomorphology, especially plate tectonic, wherein we had learned that our crust has two layers, upper crust and lower crust. In between the two, there is Conrad discontinuity, which is transition, and the depth of Conrad discontinuity is about 11 kilometers. That the depth of Mariana Trench, and there is no uniformity in upper crust and lower crust. Upper crust is also called continental crust, made up of mostly granitic structure, and the lower crust is also called oceanic crust. On the basis of these, continental plates and oceanic plates have been demarcated and defined. Here, this is transition, and above transition, this is continental shelf, part of continent, but now covered with ocean water. This is continental slope, part of continent, now covered with water, and marginal plateau and continental rise also belong to the continental part, while this trench and deep sea canyon and this abyssal plain are of oceanic nature, which are made up of basalt. So, while studying ocean bottom relief, you have to adopt two approaches. One, with increasing depth, their sequence, their importance, and then tectonically it should also be made clear which is oceanic and which is continental. The study of this ocean bottom relief has some applied aspects also, which we will be learning in the coming chapters, but some applications are here. For example, can you tell maximum fish in which of these zones? Maximum fish will be found here in the deep sea canyon or trenches or along continental shelf. Certainly here in continental shelf. Why? Because the large amount of insolation will be received here, and here phytoplanktons will develop abundantly, causing the rich availability of fish here. Second question is maximum pollution in which zone? So mine is not going here to pollute either by submarine nuclear test or other works. Rather, the pollution from land will reach first here. That may be industrial pollution, urban and agricultural chemicals. So, this continental shelf is polluted largely. Next point is here maximum salinity in. Maximum salinity will be found in the deepest part because saline water is heavier, having maximum density that sinks down, and this sea level or this coastal area will receive some rainwater which is fresh and which will decrease the salinity. From land, rivers, glaciers will also supply fresh water, hence here will be less salinity. As the depth increases, the amount of salinity will also increase. Next point is maximum terrigenous deposit in which zone. Terrigenous means pertaining to land. From land, wind, river, glacier and marine waves all carry down terrigenous deposit. Those may be of biotic and abiotic nature, and they are deposited, and those are deposited along continental shelf. Next point is the most rich marine biosphere will be found in which zone. Here will be minimum amount of biosphere because here neither insolation can reach, and here neither fresh water can reach, and here neither high temperature can reach. That's why here water is maximum saline and it is dark, there is no light, photosynthesis cannot be done, and here temperature is much less, about minus 2 degree and minus 4 degrees Celsius. That's why minimum chances of growing phytoplankton and zooplankton. Contrary to it, here insolation is found in abundance and fresh water is available, water is warmer. That's why here phytoplanktons grow in large amount and resulting into rich zooplankton. Thus biosphere is richest and on the continental shelf. Thus these are some of the questions which you should answer and discuss these things in detail. And if your concept of ocean bottom relief with two approaches is clear, first approach is with increasing depth, their names, depth and characteristic. Second, its tectonic approach. Then you can make a number of applied questions, and today oceanography is very much applied in behavioral science because thus humanity is fed up of this land. Land is getting salt and marine resources are sufficient, and that's why we and our technology is seeing towards the ocean, and the study of ocean is very important today.